Let's take a look at number 13. I'm doing it because it has unknown constants. The lowercase a, the lowercase b represent some unknown constants. Doesn't change how we're going to approach the problem. Just means you need to be a little bit more careful as we move forward. All right. First off, notice that it meets the degree requirement. The degree of the denominator is at least the degree of the numerator, so we're good to go. However, the denominator can be factored. So let's set it off by bringing down the integrand and at the same time factoring in x out of the denominator, leaving it as x times x minus b. And let's set up our partial fraction decomposition. We have unique linear factors, so each factor in the denominator is going to get its own fraction. And again, because these denominators are linear, the numerators will be constant, so capital A and capital B. It's okay to use the same letter if you use lowercase and capital, as long as you're careful. All right, let's clear out the fractions. And to clear out the fractions, we multiply both sides by x and x minus b. On the left side of the equal sign, it will cancel the entire denominator, leaving ax. On the right side, in the first fraction, the x's cancel, leaving a times x minus lowercase b. And on the second fraction, the x minus b's cancel, leaving b times x. And now let's choose some values that will zero out each of the factors that used to be in the denominator. For the first factor, x minus b, let's let x equal b. The fact that it's an unknown constant doesn't change how we approach it. If we let x equal lowercase b, then the left side will become lowercase a, lowercase b equals, this term will disappear because putting in b for x gives us a factor of 0. And over here, we get capital B, little b. But keep in mind that we are solving for the numerators, the capital letters. If we solve this, this implies that, well, actually it implies one of two things. Excuse me. I was looking at the problem in the book to see if it made any stipulations about lowercase b. This implies lowercase b equals 0 or capital B equals little a. Because if lowercase b was 0, then both of these sides would be 0 no matter what lowercase a or capital B would equal. If b wasn't equal to 0, we could divide both sides by lowercase b and get uppercase b is equal to a. I'm wondering what would happen if lowercase b were equal to 0 in this problem. If it were, then this would disappear. Then we could cancel one of the x's. We would get the integral of a over x dx, but that's just a times natural log absolute value of x plus c. So I bet that this answer will be represented in the general case if we just let b equal to 0 at the end. For now, let's just pretend b is not 0 and run with the fact that lowercase b is equal to, I'm sorry, capital B is equal to lowercase a. So we're going to go with this one. Well, we'll go revisit this at the end. But to get rid of the second part of the addition problem, we're going to let x equal 0. On the left side of this equation, letting x equal 0 will give us 0. Here, letting x equal 0 will give us capital A times negative b, which is negative capital A lowercase b. And then putting, I feel so stupid. I'm going to keep going with this, but you'll see why I feel stupid. Putting x equals 0 here will kill that off. So we get 0 equals negative capital A divided by lowercase b. And remembering that we're solving for capital A, if we assume b is not equal to 0, then this tells us that capital A is equal to 0, which means that this isn't even there anymore, and which makes perfect sense in retrospect, because at the beginning I should have noticed, I can't believe I overlooked this, I was so consumed by the partial fraction procedure. We had a factor of x on both sides that would cancel. Oh my gosh, I feel silly. I could start the video over again and just pretend that this didn't happen, but you've seen this in class, that sometimes you just get so hot and heavy into a problem You don't take advantage of the structure that's presented to you. And in this case, the structure gave us factors that would cancel. Notice that the partial fraction decomposition is giving us the exact same result. That if we put in 0 for capital A here and lowercase a for capital B here, then we're just going to get this fraction with the x's canceled. So it's not, what we did isn't wrong. It just wasn't the most efficient move, because if we were paying attention and thought about algebra before calculus, we would have noticed that right here, the x's would have canceled and left us just a over x minus b dx, which is easy to integrate. But then again, partial fractions didn't do us wrong. We just took the long route when we could have just factored and reduced the original rational function in the integrand. This is going to be the natural, left off the a. It's kind of sitting there. Natural log absolute value of x minus b plus c. I did this one because I'm looking at number 14, which also has unknown constants, lowercase a and lowercase b. I don't think it's going to succumb to, in fact, I know it won't. It's not going to fall into this particular category where, oh, we didn't have to do the partial fraction decomposition. We could have just factored and reduced. But I just wanted to demonstrate a problem that had some values that we were not sure of, namely the lowercase a and the lowercase b, but it doesn't change our approach. What changed our approach in this one was the fact that we could factor and reduce the original fraction.